Today we're going to talk about scroll compressor operation and different methods of capacity control using scrolls. In order to do that, we're first going to explain how the compressor works. A low pressure, low temperature gas is sucked into the compressor and it's forced into smaller and smaller gas pockets until it eventually discharges out of the compressor as a high pressure, high temperature gas. This compressor technology has been around for a long time. It's time tested. It's been used in residential, commercial, and light commercial applications for a really long time. In older systems, compressor was just cycled on and off in order to satisfy the controlling sensor. So with a thermostat, if the space temperature got too warm, the compressor would turn on and run for the amount of time required to satisfy the load. Usually the compressor had a minimum on-off time in order to not overcycle a compressor, which was typically 5 minutes. And this has been used in package units and split systems. The next kind of version of capacity control is a two-step scroll. And the scroll operates in the same manner, except that it actually has a couple of bypass ports that can open and close to allow some of the gas that's being compressed to bypass back into the suction side of the compressor, basically reducing the amount of refrigerant that's flowing through the system. So you get about 65% capacity or 100% capacity, and that works well with thermostats. Any thermostat that has two stages of cooling, a Y1 and a Y2 call, can be used, and this allows kind of a simple way to reduce capacity without having to get complex controls. You do get a little bit of an increase in efficiency due to the scroll not having to work as hard when it's bypassing some of the suction gas. About 10 years ago, 11, 12 years ago, they introduced the Copeland digital scroll, and this is a fully variable capacity compressor that allows between 10 and 100% of capacity. And and I'll show you how this works in the next slide, but there's a solenoid valve that can open and close that allows the rotor and the stator to separate, and that gives you basically a linear reduction in power consumption as the compressor loads and unloads. And this allows for much tighter precision temperature and humidity control, and you can satisfy set points to half a degree. It's used for smaller tonnage DX VAV systems. It's used for dedicated outside air systems. It's used for laboratories and ORs where you need to keep tight temperature and humidity control. This compressor also comes with built-in safeties where the digital compressor controller is monitoring suction pressure, it's monitoring discharge temperature. And either of those get out of range, it'll actually unload or shut off the compressor. The way that this compressor works is when their solenoid valve is opened and closed by the compressor controller, it actually allows the rotor and the stator to separate by a small amount. And when they separate, you're actually stopping compression. So this operates on a 20-second timed cycle. So if you needed 50% power, you'd be in the loaded state for 10 seconds and then the unloaded state for 10 seconds. And this requires a 1.5 to 5 volt DC signal from a unitary controller. So you're going to have a little bit more intelligent controller that's going to need to basically send a demand signal to the digital compressor controller, and it's going to unload and load that compressor to match the load that you've required. So this has got great oil return characteristics because when you're in the loaded state, you do get full refrigeration flow and velocity. So you don't have oil fallout issues with digital compressors. You're getting full velocity for some amount of time, and then you're getting basically stopping compression for some amount of time, so that oil gets entrained during the fully loaded state and gets back to the compressor. You're not going to use this for a simple thermostat. You would not provide a digital compressor and a single stage thermostat or a two-step thermostat in this case. Some of the compressor sizes do have a noticeable pitch change when they load and unload. It's more pronounced in the much larger compressors. So if you're in an acoustically sensitive area, there's things that can be done to kind of mitigate that pitch change, whether it's a compressor sound blanket, a spring vibration isolation rail, or even acoustical dampening inside of your roof curb. So that can all be mitigated. It's just something that you need to pay attention to when you're designing systems for acoustically sensitive areas. You do get a linear power reduction, as I talked about. So when you're at about 50% capacity, you're at 60% power. That is a linear straight line relationship because you're loading and unloading that compressor. But there are some energy savings to be had when you're using one of these compressors when they're precisely matching your load. The third method of capacity control is actually a variable speed scroll. So this is a VFD driven compressor. There is a separate variable frequency drive that's mounted somewhere close to the compressor that's going to vary the refrigerant flow rate by varying the scroll speed. This does require a factory controller. It is a little bit more complicated. You've got an electronic expansion valve that meters refrigerant. Oil return has to be addressed. Typically, oil fallout begins at around 1,000 feet per minute, which can occur, around 50% capacity. And the controller has to have timed oil return, where if it's operating under a low load for an extended period of time, then it's going to have to be sped up to full speed to make sure that all the oil gets back to the compressor. So most manufacturers are not going to allow a third-party DDC contractor to control one of these compressors. It's going to be under the responsibility of the manufacturer to control it. It is more efficient, but there is a limitation in turn down. Typically, you're going to get about 50% as the minimum that you're going to be able to do with one compressor. And you're going to have multiple compressors in order to get the turn down that you need for most applications. So all of these slides are basically parts of my lunch and learn called direct expansion processes for packaged and split systems. So if you want to dive down deep into compressor technology, heat pumps, modulating hot gas reheat, precision temperature control with DX systems, then go ahead and if you're watching this on YouTube, click on the Calendly link below. Calendly is an app that lets you schedule a lunch and learn. I've basically put in all of the times that I'm available to do this lunch and learn, where I could come to your office and cater in lunch and do an hour-long PDH session for your office and your firm. So give me a call if you've got any questions, and I look forward to hearing from you soon.
Your project. In the world of commercial HVAC, we know that whether you design, construct, own, or maintain buildings, you need a partner committed to getting your project done right, on time, and on budget. Welcome to your network of partners, connecting more than 20 offices across the country with over 500 associates working together, delivering the right HVAC solution for your project. One national network with one local purpose, your success. Because working together, we're stronger. Insight Partners.